to do. Could somebody come?
Hi everyone, welcome to New Tech. My name is Miles and it's fantastic to have you here. Now in today's video, we're going to be checking out my 4th Axis dedicated CNC machine. So let's go. So I've had my Workbee CNC now for a couple of years and I've been really happy with it. And ever since I purchased it, I did want to add a 4th axis, that's a rotary axis, onto this machine. However, after playing around and trying to figure out how this would work, I realized there was just not enough height in this machine to add a 4th axis unless I wanted to embed it into the spoil board. And that's something that I really didn't want to do. But I also realized that I had to ensure that every time that I went to use the 4th axis, that I would have to realign the machine every time, make sure it's square, and ensure that everything was plumbed to the rotary axis. So I kind of gave up on the dream about adding a 4th axis to this machine. And also a couple of years ago, I created my CNC table to make sure that my life using my CNC was a lot easier, but I also made sure that I had some space to put my tools and everything in a drawer. Under the machine on that side, I have my electronics, I have my vacuum cleaner, I have my pump and my water cooling system. So I've packed everything into the one unit and it's all on wheels, and it has been fantastic to save space and to move this machine around to where I want it. So time came where I had a massive void on this side of the machine. It was a massive blank spot. It had been sitting like that for a couple of years, and I always knew that I wanted to add something else into that space. And so in today's video, I would like you to join me on my journey on creating my dedicated 4th axis CNC. Now, this is not a typical build. This is certainly one that takes a lot of different techniques, adding it all in to create my CNC machine. Now, I tried to do it on a budget, but unfortunately, as you can see through the video, that things turn upside down a little bit, especially when I'm using the spindle, but I'll leave that for later on in the video. But pretty much today's video was about challenging my ability and also challenging my design process in creating something, and hopefully on the cheap. And I did make most of the stuff on the cheap, especially from using leftover parts from previous builds to make the machine, and using my 3D printer and my current CNC to make a lot of the components that you will see through today's video. So what I'm going to do, I'm going to start with building the electronics, then moving on to the build of the machine and testing it out to see what it can do. So guys, let's jump into the build. So with today's build, I'm going to start with the electronics. You can see here that I've made a very crude CNC cut electronics box. There's a couple of things I really like about it, and that is that I can pre-cut a lot of these inserts for my buttons and things just to be slotted straight into. A downside to this is that it's not metal, so it's very hard to earth all the electronics, and I'm going to try my best using wires to earth it. There's a couple of things too that I did add to this build. So on the inside of the door panel, I have put some magnets, and that just makes it super easy to slide anything into it. Putting the door in, and that just should lock into place. And then if I need to do any maintenance, I can just take that panel off and then have access to the inside. Now for the installation today, I have just loosely fitted each of these panels, so I can take them apart if I need to fit in the electronics. And I also have done all the electronics or the wiring looms in preparations for today's video. Now you can see here that I've used the aviation plugs on here. They're just super handy because they screw straight in your connections, and just ensures that nothing falls apart. It makes a really secure connection. Now this takes the most time out of the entire build overall, is to do all the wiring, and so I'm really pleased to get to this stage where the wiring is complete and I can really enjoy the build process from now. So I'm going to jump into a time lapse from now. I'm going to put all the electronics together, and hopefully I'll see you shortly to explain about some of the components that I put in today's build. So stay tuned. All right guys, I have now finished the electronics box and I'm really pleased with the result. I just wanted to run through a couple of the features that I have included with this box. As you can see here on the front panel, I have a couple of switches at the top. Now these are kind of like dead switches, so it means that I can physically switch things on and off. They're not software controlled. I much rather this way than having to fumble around on the computer to turn something on or off. So I have my motor control, so that's the stepper motors. I can turn them on and off. I have my LEDs, but also with the LEDs that's linked to my fans I'm going to be using on the stepper motors. The reason is because I'll be using some plastic parts, I don't want the motors to get too hot and then consequently melting or misshaping those 3D printed parts. I also have manual control over my spindle as well, so I can turn that on and off. And that's also accompanied by the potentiometer for the spindle control. Now I do have the option to enable software control through Mach 3 software. However, because I've never used the 800 watt spindle before, I'm a bit concerned about overloading it and needing that instant control to either turn it up or turn it down. So for the moment, whilst I'm just getting used to the new spindle, I wanted to have that manual control there. So that's there ready to go, and that's also accompanied by the laser engraving that I've done on the front face there. Now, most importantly, I have put an e-stop in there. That just kills everything instantly. If I need to hit that, it turns off everything and there's no more power going to the machine. And down the bottom here, I have put a pause and a resume button. So if I do need to access those quickly, and once again not having to jump onto the computer and try and find the right button to pause what I'm doing, they're just there for ease of use when I'm running the machine. Now on the back here you can see that I've used my aviator plugs. They're secured in the back here, and so I've got the y-axis, the z-axis and the rotary axis there, and down here I have my plug for my limit switches. And also I'm going to be including a temperature thermometer on my spindle, and there's going to be a screen above it to tell me what the temperature is, because once again I am using some 3D printed parts in this and I want to monitor how hot the spindle's getting, because kind of my experience with using spindles and plastic parts is they do sometimes get a bit warm, and those 3D printed parts can become a bit squishy and not very reliable. So that's why I've included the temperature gauge that I can monitor the spindle at all times. Down the bottom here I just have two 12 volt outputs. So one is going to be for my LEDs on my machine, so I'm going to be using a ring light at the bottom of my spindle, and that's also linked in with the fan control on my motor drivers. And this one's the second one is for my my roof lights. So in the space where it's going to be installed, I'm going to have some LEDs across there that this will have direct control. And once again, that that button at the front of the machine will be able to turn everything on and off at the same time. And then finally down here I have another aviation plug that is for the spindle output. It's only a DC one, so it only uses your plus and minus, so I didn't need all four connections that I have there. But if I wanted to upgrade that to something much larger later on, I do have that opportunity to use the 4 different pins if I need it. And at the back here I do have the air vents out, and down the bottom here I do have that jug plug switch on and off. That's to have the power into the machine itself. Now if I turn around and have a look at the front, you can see that this has been put together. I have the magnetized door on the front, which works super well, and then I have the inside. So there's a couple of features that I have included here. So at the moment nothing is plugged in, so it's completely safe to have open, and I'm able to do some wiring. Now I have put an inspection light just on the inside of this frame, which is just a LED strip. Now that is powered independently via this DC input down here. Now it just means that I can apply light into the electronics box. So if I just plug my 12 volt in the front here and switch it on, I now have access to see what is inside this box here, and it completely isolates the power from having to use the power input at the back, and consequently being live power inside here as I'm working on it, and that's something that I didn't want to do. So having that 12 volt that just powers the LEDs on the inside of here and totally isolated makes it much easier to fix any problems. And so I wanted to go through the items that I've used inside here. So on the front face here, I have a 24 volt, 120 millimeter, it's like a PC fan, pretty standard fan, but it's at the front here with a filter on it as well to stop large dust particles coming in. So that's at the front, it pushes air in. Because it's a closed box, it creates a positive pressure on the inside of this box and allows air to be pushed out all the little holes around the box. And that also helps with, stops any dust from seeping inside this box, especially when it's used. So I have at the top here my motor drivers. These ones are the TMC 2160 motor drivers. Now I've never used those before, and I was quite excited to try these ones for the first time just because they have that silent ability. Not like silence is going to be something that the machine is going to need, but I wanted to give them a go because they looked pretty promising with what they could do. Now, as you can see, that these have actually been mounted onto their own fan themselves. So at the back here, we have a void that allows the air in, then the fan pushes the air through past the motor drivers, keeping them cool at all times. So it's this kind of cycle of air coming in the front, being pushed around these motor drivers, and then being either pushed out the back or through the holes around the casing of this. At the back here, I have my Spindle power supply. I have my main power supply for my motor drivers and other auxiliary items like the LEDs and the fans. And down the bottom, I'm just using one of these really simple Mach 3 USB cards that is compatible with Mach 3. Now, I have seen a lot of people pretty disappointed with this card, but to my knowledge, it looks pretty good. Looks like it could be a really great card to use. So it's going to be a bit of a trial and error for me. I can always purchase another one and swap it over because I have put it down the bottom there just in case I did want to replace that card later on. Yeah, but it's all there ready to go. I've got some buck converters down the bottom there. They're just converting the 24 volt down to the 12 volt for any LED and fan that I need for this. At the front here, you can see that I do have the USB connection for the PC. So that's ready to go, and that's being anchored into the front of this box with a 3D part. It just makes sure that this doesn't pull out or no dust gets in that same hole there. So I'm going to just swap over my control there, and for fun, I'm going to plug in my spindle on the side there. So I'm going to plug it straight in on the side and close that off. Grab this. Okay, so I've plugged it in at the back. It has been switched on. So I'm just going to release the emergency e-stop. And you can see straight away, it's a bit hard to see, but you can see a ring light around the resume button, and also the pause button is orange. You can see that none of these lights are on at the top. They are all being switched off, so that means nothing has been enabled yet. You won't be able to see anything, even if I do turn the motors on. We won't be able to see anything happen until I actually start to use this with the machine. Same with the LEDs. Spindle is something certainly that I can turn on from here. And this should be manual control at the moment. So if I hold the spindle in this hand and gently turn this axis, okay, and then you can see it take off straight away. So it's a pretty good spindle. It's decently quiet. So everything is up and going. I just love it. I love the part of the build where everything just comes together and it just works. So I'm going to turn everything off now, hit the e-stop there, everything is shut off, and then I can go ahead and disconnect everything ready to start the second part of this build, which is building the rotary axis. So let's get started. All right, so I've gone ahead and I've pre-cut everything already on my CNC. Now this is on a 16mm MDF that I've cut out on the Workpiece CNC and I've pre-assembled already. Then I've gone ahead and spray painted black. Now that's mainly for stylistic purposes, and also the reason if I want to do any filming, it just stops any reflection of light for these things. So they should be really solid ends for my rotary CNC to stay strong. They've got the angle supports there, so I hope that I don't have any issues with these, and I don't think I will. The other thing too is I've 3D printed all my parts, and I've already inserted a lot of the bolts and the bearings as well onto these parts, just to move things a little bit faster today. And this is for my Z-axis, so it's a dual motor Z-axis, and that mounts in there and goes up and down. Now I've decided to go with dual axis just because it keeps it nice and even when it's going through the main gantry here. At the front here, you can see that I've used a T-slot aluminium profile. Now the reason for that is, well, I don't have access to a lot of V-slot aluminium profiles around my area. So the T-slot was the only one that I could get hold of. So that's mainly just to keep the axis true for my rotary part. So here's the chuck for the rotary part, and as I slide that end in, just keeps it super true and stops any movement, and if I was to use wood or any plastic parts like that. So the other part too is on the rail axis for this one here, I've used a 25mm solid bar for that. So that's to eliminate any inconsistencies or dipping in that rail altogether. So I hope that that kind of sorts out a lot of the issues that I did when I made the MP CNC. So this is kind of a lot of things that I've learned along the way, and a lot of things I want to improve. So, and as you can see, a lot of things that have been inspired by the MP CNC. So let's get into it. Right, so I have installed everything into the machine already, and it's working really, really well. I did do a lot of stuff off camera to get this up and going to where it's up to now, just because I needed to focus, and filming all the time does take quite a lot of time when you're trying to do two things at once. So the electronics work really, really well. The spindle control there is fantastic, and also having those quick feed hold and start button. I'm still working on the start button, don't know why that's not working, but the feed hold does work, which is perfect, exactly what I need. I have got the whole machine's working really, really well. I'm just going to put the camera down. And so as you can see here, I've got my my Z-axis up and down movement, and I've also got my X movement. Now I have changed this part to an X axis instead of the Y axis because Fusion 360 with the post processor that I was using, it really didn't like me using the Y axis as the rotational axis that it goes along with. So in other words, this rotational axis underneath needed to be aligned with the X axis instead. So I just swapped everything over, and so now I've got X axis, no Y axis, the A axis and the Z axis. Now my worst nightmare has come true, and unfortunately I did run one cut with this, and that's what you can see here. You certainly couldn't do this shape on a lathe, but on this type of machine that's worked out really, really well. I did spend a lot of time though in dialing this machine in. So it's the first time working with a rotary axis. I've never worked with one before, so there's a lot of learning that has gone with this project. So I figured out a way how to calibrate the A axis really, really well and with a lot of precision. I'm really happy where it's at the moment, but there's a couple of things that I need to improve on this build. So as I said, my worst nightmare has come forth, and I'm really glad I installed the thermometer up on the top so that the probe is actually right on the spindle. It started to escalate the temperature pretty much into a couple of minutes into the cutting, and it started to hit the 50s, 60s, and then started to head towards the 70 degrees, and that's what I didn't want to happen. So essentially what happens is the spindle that you can see there is the 800 watt spindle, and it's fan cooled. The idea is that the fan feeds air through the middle of the spindle and cooling it down as it goes. But the other thing to it, it relies on whatever it's tied into to help dissipate the heat from it. So traditionally with that spindle you'd be using it on some type of CNC where you'd be tied in with some aluminium block, and then what happens is the heat transfers into that block and then into the rest of the machine, helping cool the spindle. Now there's two things that could go wrong. First thing is that the spindle will overheat if it's not cooled down correctly, and that means that I'll just lose the spindle all up. The second thing is, because I'm using plastic parts and plastic brackets, you can just imagine the worst is going to happen is that plastic will melt and it's just going to fall out and cause an absolute chaos. So I decided that I didn't want to do any more milling until I had sorted out this problem. I was a little bit disappointed because I was really excited to use this spindle. So I came up with a couple of solutions for this. The first solution was to mill my own aluminium brackets for this. So you can see here that I've put this in. I was going to put some vertical pieces of aluminium in there, enough for it to be strapped onto the posts. And this was just going to help it take the heat away from the spindle and take it into those posts and just spread it out a little bit more, and also give it some rigidity as well. And just something that I knew that if the spindle did overheat, that it wasn't just going to fall out of its brackets there. So that was the first fix that I could do. The second fix I could do is add some other cooling fans to it. So I did a test where I did put some fans on the outside of it to see if that made any difference, and to be honest, it made no difference at all. So that was out of the picture. So I feel at this moment that, you know, I'm in that boat where the holes keep on appearing in the boat and you keep on plugging in, you know, fingers and all and toes, and you're coming to a point where there's just too many holes to try and cover in and you're not sure if you're ever going to find the solution for this spindle. So at this stage, I just decided I'm going to get rid of that spindle altogether and use it on another project down the track. So I know this is probably really unnecessary for this machine, but what I did a while back is for my work bee CNC is that I had a 2.2 kilowatt spindle and I burnt the spindle out. So what I did was I just took off that VFD and the spindle and I put it aside, and I got a brand new VFD and spindle on the machine. So I've still got those things behind, so the VFD is absolutely fine, there's no problem with it. So I just decided, you know, to keep things cheap, that I'll just get another 2.2 kilowatt spindle that I'm going to use on this. Now, it is overkill, but the best thing about it is that it is water cooled. That means I don't have to worry about heat. I can still use plastic parts as the brackets, and I don't have to worry about that spindle getting too hot and falling out. I will keep the temperature gauge on there just so I can keep an eye on that at all times, but I don't have a problem with it. So what I'm going to do now is I'm going to swap this whole center section of the gantry over and put a 2.2 kilowatt spindle in there and give another run, because I think that's going to answer all my questions, and it also means that I can run it for a long time, and I can feel very safe about running this spindle for a lengthy period. So hold on there guys, I'm going to quickly swap that over and let's see what happens. And well, there you go, I have installed the 2.2 kilowatt spindle and I'm really pleased with this upgrade. As you can see at the back there, I have the tubes going around for the water cooling. I've just got some car coolant in there going into the reservoir down here. My VFD is installed at the back there to keep it away from the electronics. And I was a little bit worried about how my NEMA 17 motors would go, and look, there is absolutely no problem because of that dual NEMA 17 motors at the top there, and I'm also using that solid bar across here, so there is absolutely no warping, there's no stress on the motors, and because I also have the active cooling on the motors, that works flawlessly as well. So I've also reinstalled my dust boot as well. I am going to be upgrading the dust boot as time goes on, as I figure out what I do need, but that's a magnetic dust boot, just clips on, and then I can detach it so I can vacuum around the area when I'm finished. I'm still going to be figuring out the hose through the wall there, so that's something that is a project for later on. I've got in my head what I want to do, so it shouldn't be such a big issue, but here we go. I have upgraded and solved a lot of my problems here, so really pleased. So let's jump into what this can do, and I want to have a bit of a play around with the different types of rotary axis cutting or milling that you can do. So having a play around with a milling that works on a circular axis as well as one that works along the x-axis there and just turning slightly every time it's passing over, plus also having a play around with the flat end mills versus the ball end mills as well, what works best and what I can also achieve with just one end mill altogether. So let's have a look and see what this machine can do. I'm absolutely blown away by the capabilities of this machine. I did go through a couple of reiterations on having to figure out how the machine cuts and coming up with some solutions on how to fix things. So things didn't work perfectly off the bat because I hadn't figured out how to best cut things, and there was a lot of learning along the way. I even had a bit of a mishap when I first started to cut my Groot, and unfortunately almost took off his head, so I had to restart that one. But nevertheless, the second time around, as I started getting used to the machine, things started to fall in place really, really well. So this one is my twisted cube, or it's just a test file really on testing out the machine, making sure it's well calibrated, and also I wanted to try something that was pretty much impossible to do via using like a normal lathe. And so this file here, this came out really, really nicely. And a couple of things I really like about it is how you can see the different grain through the timber as it spins around, especially this type of timber that I was using for this one. I think this one here is a silky oak timber, and it has a really lovely grain and a beautiful fleck when you just get it on the right angle. So it works out really nicely if you want to get that grain of a timber that stands out a lot. So this file worked out really well. And a couple of things I did learn from doing this type of file is that it's really important to make sure that you have some type of gradual cutting into the stock as you begin to cut, because otherwise going straight into it straight away, and then as you start to cut it, you can imagine that you might skip some steps because that aggressive first cut. So I kind of made sure I did a tapered entry into most of my cuts today. So that one worked out really well. The second piece that I decided to do was my crochet hook. Now, the crochet hook worked really, really nicely, and I wanted to try a different type of cut from this one, where traditionally you'd go around and spiral up the piece, and then this one is just using the X-axis and slowly rotating as it passes up and down the piece. So this was a really nice way for me to figure out which kind of cut works best for what operation. So this worked out really nicely because I only used one single tool, and I would consider maybe this one being a one tool wonder. I used a 8mm flat end mill. Now this was a cob end mill, so it was quite aggressive. However, because it was going along this way, it actually coped with doing a lot of the curvature on the piece itself without having many steps within it. So, and also going with the grain, I found it was much easier to finish it off afterwards than going against the grain and then having to smooth out any of those lines at the end. So a couple of different things that I learned straight off the bat when I started doing a lot of this rotary cutting. Now, the very last piece was a 3D contour piece of Groot. Now, the reason I chose Groot, well, because he is a tree, I thought it was fitting to do a Groot for one of my three-dimensional carves. And as you can see here, that I couldn't do obviously at the top of it. If I cut the top off, he would fall off, and also at the bottom of it. But all in all, like, this has just been absolutely amazing for me to experience and to do a different type of carving where I traditionally wouldn't be able to do it as easy using a traditional CNC machine. Having that rotary capability has just been able to extend my creative capability in the shed and doing my projects. So I was really happy about my Groot, and especially all the fine detail that I was able to pick up using, I think it's a 1mm ball end. So I am so blown away by the capabilities of the machine. And about, this took about an hour. So to do that on this machine was certainly a bit of a stress test to see if it was capable of achieving the things that I wanted it to, and it did that flawlessly. So that kind of ends up today's video in my exploration and build of the 4th Axis CNC machine. And obviously that this is a bit of a prototype, it's a bit of a project kit, and I have put the files down below. If you want to check it out for yourself, I've put the build files Now it's obviously there just for a bit of a play around, see what you can do, but it works extremely well, and I'm really happy about the overall build and the strength of how I've been able to utilize the 3D components or the 3D printed components for this build. And I've also added these files in below to test. If you wanted to build this as well, you can certainly go check it out on a couple of these test files on your own 4th Axis rotary machine. So guys, please support me by subscribing to the channel, give me a thumbs up, and if you do want to ask any questions or give me some positive feedback, please chuck it in the comments down below. But certainly in a community of like-minded people, I like to do this stuff to get it out there, to get people thinking, and even getting people to make better versions of what I'm doing as well. I like just to be part of that community and giving back to the YouTube community that I have learnt so much from in the past. So guys, please consider supporting me, and I will see you next time.